what we do is more than a pretty picture. The designs we create are not just the model and the picture and the get to a sales contract and that's it. Where the real challenge that design comes in is being involved in the design development drawings, how to get to the next level of just beyond the concept stage, and then what you're doing as far as the construction observation, seeing the job go through and make sure you're answering details in that. So design, once we've got the contract signed, everything's done, we now move into design development drawings. These where you create the vision in the concept. This shows you how to build the vision. Really, it's the most important part of your design is about to begin, is how to make it actually happen. So it goes from paper to reality. This is a project we're building right now. Chad's building it. We designed it and put it together, and you can see the spatial theme pretty obvious.
There's the circles. There's the circles.
Not one straight line on the whole thing. So, that's right. Other than the connectors, other than that. So, a lot of fun doing this one, to say the least. But
yeah,
really, how this starts to come together is a big part of it. So there's several sets of design development drawings that we produce, that you can produce. The first is the permit approval set. So, and this is, some of you may be doing this already. That's where you're, whatever is needed for code for your community, impervious surface ratios, layout, setbacks, tree protection, canopy, all those things come into play. Some places are easy. You can do it on the back of a napkin. Some places are beyond difficult, damn near impossible, but you still have to be able to produce those drawings as well. And sometimes we'll have some of these are, 30, 40, 50 hour drawings to be able to answer all the things that communities want, what they're doing. The second set, really the main set of drawings that we end up doing, are the water shape design development drawings, DD design development. And I'll show a little bit more of those primarily in a minute, but that's where we're doing showing everything about how the pool works hydraulically, making that come together. Third set that we do, and this is Dakota does a lot of this for us, is the architectural set, where we're looking at pool houses, pavilions, structures. Anything that's a structure, we want to outline how that's built from a design and from a engineering standpoint. Fourth step is getting into hardscapes, where we're doing the decks and patios and retaining walls and outdoor kitchens and fire pits and features and specifying, showing how those are built with details. And the last thing we do are the landscape sets, where we're plants, irrigation, lighting, AV, getting everything through the final parts of a project. So the design is really just beginning when we finish the drawing that most people say is the design drawing. And these take us through the whole project. And typically the permit is obviously before you start. The water shape is before they start. And depending on how much architectural is necessary, that is either before it starts or kind of early in the process. We typically don't do the hardscape and landscape until later in the construction. So it's as things are changing a little bit, or as so you don't have to have all of this in place before. You don't have to know what every shrub's going to be before you break ground on the pool. So. The water shape set is the main one we end up producing, and that's really answering all the questions about a pool. And Hunter is the main man that does all of these beyonds. Sure enough, I think he dreams about pipes and sizing and color codes and all those things. Probably doesn't, but he lives it. So there you go. Plumbing, pipe size, flow rates, velocities, equipment pads, sections and details. That's all part of the plumbing set. I'm actually gonna share a different screen. Kind of what one of those sets looks like. So
you do have to set aside good money for like 72-hour hold at a mental institution after doing one of these. So That part's costly.
Yeah, true that. All right, where is PDF?
Jason, are these hydraulics revised by the manufacturers?
Um, who asked that? Is that Gerson?
That's me.
There you
Yeah.
go. That's
Save
right.
some.
I'll chime in if you want me to, Jason.
Yes, please do.
So it's kind of a daily thing of going through these, and my computer is full of spec sheets and pump curves and manuals and all the stuff that, yes, the information does come from the manufacturer. However, you have to know how to be able to read it, and you have to be able to know how to implement it into your design. So if I know what products I'm working with and what the end result needs to be, it kind of gets reverse engineered in this. And you end up looking at something and going, hey, okay, Garrison called me and he wants these 3 damn laminars in there now. Where can I put that? And where can how can I adjust that into my system? What is necessary for those 3 laminars? How do we incorporate that into what we've got? Does it fit into a pump curve? So now we're going back and looking at information that the manufacturer does provide. And then figuring out how to hydraulically make that happen is something that we've learned through Watershape University or through hydraulics classes that we've taken, through research. A lot of it is experience. Hey, I know that doesn't work. I'm not going to
A lot of
spend.
it's experience.
Yeah, I mean, do I put a single valve on 10 water features that are all in a row? No. Like, do I not put one on each one? No, because that's a pain in the butt. How hydraulically, there's an answer for that. How can I make that happen? And where you've not got guys sitting out there for a half a day trying to figure out how to even out water features.
And on the big jobs, we all learn something on every single job hydraulically.
Absolutely.
And what we've designed.
Hydraulics is one big math problem. And one of the favorite things I like to say is I like to create a problem in design and then solve it through the construction drawings, design development drawings, hydraulics, etc. So it's a big game. How difficult can I make it on myself in pushing the envelopes in design? And then, okay, now how do we say not only can you do this, and here's how you do it, and it answers all those questions from the very beginning. This is a set that for the one with the Wild Wild West project, but it's 30 sheets that are in all this. So, and you can see it's got a cover information. This is where it talks about flow rates and our design standards, where we're designing everything to. Everything is specified. Every nut, bolt, every line, every fitting, every valve, every pump, everything is all in these specs. I'll zoom in and see how many pipes it is, how many feet of pipes. I forgot. This is like 2 miles of pipes, I think, if memory serves.
Yeah, a little over, I think.
Yeah, a little bit over that. Every pump system, P1, P2, 3, all the pump 1, pump 2, the heaters, the automation, the lights, everything is figured out down to part numbers and quantities and notes about each one. So,
do you guys charge for that, right? Like all these plans?
Definitely.
Oh yeah,
a lot, I imagine. Yeah.
So we still our normal hourly rate, but we see how long does it take typically to do all of this. And I have that in my initial contract of, let me zoom out on this. There we go. Hang on. Oh, I'm going down, not zooming. Wrong thing. Okay. The typical water shape set is kind of a wide range. If it's more of a mid to basic pool, it's about 50 to 60 hours of time to do it. If it's a larger pool, usually it's 90 to 100 hours of time to do it, because they take time to do all of this data. And you're getting into where all the shell penetrations, where every skimmer, where every floor system drain is located, etc. This one I think was close to 200 hours for this set. So just to be able to put it all in floor systems, tying in where all that's located. We work a lot with Hayward and Paramount are our 2 main suppliers we work with. and where all the heads are located and how they tie in comes into play. Drawing sections of each piece or each area that shows water depths and pool profiles and step entrances and everything that goes with that. You got rock work in this case, and boulders and geysers. And then the plumbing is really where we're getting into detail work. And you can see each pump line is color coded by the pump system that it connects to. Zoom in on something over
What
here.
program do you do the plumbing in?
AutoCAD right
It's in
now.
AutoCAD?
I think we're going. Are we moving to Revit for that too now?
I don't know. After I looked at all these, I don't know that I want to do that.
You don't know, yeah. Hey, you're the one that asked for it, so you're in. Gotta be now. So
Hunter, what would be the difference between AutoCAD and Revit for the hydraulics? What would it give you a plus, or would it just help on what?
So again, the modeling information right now, these are lines. So what we're going for is drawing integrity. We're going for consistency. We're going for what is actually in here. If you zoom out, Jason, these are nothing but lines that I have constructed or that we put on a sheet of paper and say this line is, and label it. So the constructive part of Revit and some of these other softwares that are out there is you can make this an actual 3-inch pipe that is a Schedule 40 PVC, and it has X, Y, and Z fittings on it. You know, we're taking these as line segments and creating a drawing that makes sense to us as somebody that can look at a set of hydraulics.
schematic plan, right?
Right. You look at this and say, hey, there you go. It says what it is. It must be what it is. So having a little more integrity put into that means, you know, hey, this actually works. This is what's going on here. This is the actual pipe. This is the actual, you know, we're able to log in some.
It's amazing. It's amazing because AutoCAD does not give you all the fitting count, right? Like Revit would.
No. You have to draw it. You know, I mean, you could draw each fitting, but you're having to draw one individually, everything. So no, it does not give you anything. This is just like your hand drawing. It's the same thing in AutoCAD, where Revit gives you some data points to it. So
a question for Chad.
Awesome.
A question for Chad. When you're in the field and you have this plan, how accurate do you follow where the plumbing runs are? I mean, I understand plumbing size. You're going to
Yeah, so there's not 8 inches between each pipe.
that happened to me on a job with someone. He did. I went out there and they drove a plumbing trench was about 23 feet wide because he had each pipe lined out 8 inches apart from each other. So instead of stacking
and you're not allowed to stack it either. Apparently, because I just read some Watershed University stuff.
Yeah.
This afternoon.
So as far as it being like, yeah, okay. So as far as the lines, we use the lines, the size, the pipe size for sure. Sometimes we have to go around footers and planters and things like that, and elevation changes and all that stuff. So yeah, it's not exactly like this, but we try. But as far as the size of the pipes or the number of pipes, so, I mean, there's almost on every one of the difficult jobs, we changed it up a little bit just because of the site conditions. But as far as the flow rates and the hydraulics and the math behind it, all that is the same as this. And as far as the routes that we take and elevations and stuff like that, that could change. So even if schematic. Even if you had, even if you had all the fittings on there, and as a builder, you're like, oh, I'm just going to use that count. Well, I mean, you got to go around footers and walls, and we have all these elevation changes, so it does get. I mean, it's very close, but it's not exact as far as how we have to run the lines. But
Okay.
But it would help to a startup count pretty much.
Oh
overall
yeah,
project.
No,
Yeah.
no, it's a huge help. It's a huge
Yeah,
help.
yeah.
And I just try to
Yeah.
tell my guys, make it per the drawings, and like we can't do it exactly per the drawings. I said I understand, but
So,
the most important thing is to note is to these are all the other thing that we do. We also add additional plumbing pipes just in case on top of this, but we don't have to use them instead unless something's gone wrong with one of the pipes. But yeah, it's a great guide. It's a complete and thorough guide.
And what we're showing each one, a color code every system, every pump has a color to it, so you don't just and I get on to some builders, they'll get out there in the field and they just printed it black and white because it's a lot cheaper to print in black and white. But then you get 712 lines, you don't know which one's going to what, and the color code helps tremendously. But every one which this is pump 5, which is a spa therapy suction line. It's a 4-inch PVC pipe. It's got a flow rate of 210 gallons per minute and then it's got a velocity of 5.3 feet per second. So we know it meets code underneath there. It's within the range of what the pipe can handle and the pump can handle. And we know the pipe size and we know where it goes. So we're answering all those questions and making sure it's as dummy proof as it can be from a design standpoint. So
the other thing is we try to teach, at least especially our lead guys, what all those numbers mean. You want to make sure that more than you just don't go lollygag and just go put all these pipes in there. You want your guys to understand in the field what they're doing and why that pipe size is that pipe size. And that's one of the training things we do. And before one of the jobs start, we'll have a meeting at the office with all of us, and we'll go over the whys behind what Hunter has come up with. And we'll bring our startup guy, Will. We'll say, hey, Will, and when he also does the pads. What do you see wrong with this? What questions do you have? And we go over it all because it's so important to understand this part right here. Because if it's screwed up, the pool just doesn't work. It doesn't work on something that's this complicated.
So and we're doing this the equipment pad. We're laying out all the pipes and pumps and filters and valves and heaters, etc. So you can kind of follow the scheme that goes in the pump to the filter to the heater and out to the sanitizer and back. And each pump has a different function, and we're color coding that. So there's a lot that goes into this process to get the DD set, the water shape DD set done. So and then kind of back to that and all the called out each piece and part number, etc. So anyway, the key part of that I want to drive home on this is not just as important, it's really more important than the just how it lays out. So it all comes into play, but it has to work. And if you don't know how it works, you design something, you don't really know what you're designing. It's unbelievably important for designers to understand the hydraulics of what you're creating. If you're doing water shapes, if you're doing edge overflows, if you're doing big, grotto waterfalls, and whatever it is, you need to understand how it flows and how it functions. And that's where the water shape classes, I learned every single thing I learned was from the classes I started taking with Genesis and NWU once it changed over to that.
But to be fair and to not scare you, because these are very intimidating drawings, guys. They are. So if you've got, you first start on how a little rectangle pool, how the hydraulics work on that. And
to that point, I brought up a smaller one. It's not small, but yes, so correct. But good point. So a more traditional rectangle pool, rectilinear. This is Holder. How it lays out. Not as crazy as the other one there. So
this is just way more straightforward for them. It's easier to swallow.
And to the point of your question earlier, we went out and droned this the other day. Somebody asked the question of how closely is this followed? It's pretty close in real life. There was this one, and then the pear tree was another one that was like
I've got that in the slide.
Stunning as far as it's like I don't even know the right words to say.
Freaking
no,
awesome. is
I'll
what it
show
was,
that.
buddy. Hunter, it was awesome.
I've been
It was amazing.
recorded, so I don't know how to say the right words here.
Yeah.
But I think that the biggest thing that I hope to achieve from this is when I'm producing these, or when we're coming up with a set of these to pass on to a builder or to a client, there's very few surprises. I get it all the time where somebody goes, man, crap, our equipment pad, we don't have enough room in our equipment pad. We're getting to the end of the job, and that's the last thing. We bastardize the rest of the place that we have to work with, and we have no room to be able to do anything. And then it's crunched, and then there's no area. Same thing with pumps. The question comes all the time, whoa, why do we need that big of a pump? Or how, golly, I had no idea. I had zero thought that we would have to have that size of pump to operate this thing. The details are there, and the information is there to be able to, you can't argue with math or science. It's just there. You're either doing yourself a disservice or you're doing a customer a disservice by at the end of it going, hey, I forgot to tell you, we've got like $26,000 that was not in the budget for equipment. And somebody has to eat that money.
Mm-hmm. So having it right and budgeting it right, that's where you get into how the money plays in, and counting all your costs and pennies and knowing what it is and not guessing, because you can get screwed when you guess. This is what they're just talking a second ago about. I've got a few pictures of, using technology, we'll take during construction, go out with a drone and take a picture straight overhead, and then you can underlay that in CAD and see how exact you are. You can see in this one, this is pear tree. I mean, it's dead nuts.
Tight, baby.
Yeah, there it is. That's right. You can see all the.
And the other thing that we show our owners is like, hey, look what we did. Look how tight this is. It's just like the plans.
Mm-hmm.
It's gonna look just like the picture. Look how it's right on.
And then there's the plumbing one that shows, you can see the plumbing overlay and underlay of how it works with it actually there and where it comes in. So that's it's cool when you get it right on the line. So, and this is the curve.
This is my favorite one.
Yeah, I know. You can see that's tough to be able to get that level of precision on all radiuses. None of them match up. Everything's different, and
and no surveyor. No surveyor.
There you go. I know your guys did that. Sure enough.
Yeah.
So, but another thing, I put this slide in here kind of in the end. We've done this with a lot of people and do all the time, where we'll have some contractors that got questions or haven't done a lot in their edge or whatever, and we invite you guys to come and spend a couple of days here, see some projects, do whatever. That's something we're do a lot. And it was Jason Seneker out of Charlotte came last year, I guess. It's a picture I pulled from him, but Gerson came and spent some time with us. So
that's right.
Saw some job. Everybody's about to start one of these jobs we did, and they're knocking it out of the park. So, but see, the understanding how it's built is as imperative as anything you can know, and that's where you start. How do you eat an elephant one bite at a time? And if you look at this, you think, oh my God, I'll never get that. But you take one class of a construction class, and we're good at. I mean, as designers, and I took this. The very first class I took was the class I teach now, and it was my launching pad. It was my foreground item. It was I got a feel for what it's like. I kind of understood the concepts, obviously, because design. But the next class I took was a construction class, and that's when it starts to okay, now I'm starting to get it. I understand the concepts. And the next class you take, it solidifies some more. And then you take the hydraulics class, and then the next, and it starts building. And I mean, it's about 150 hours worth of W classes, and then you really have a great understanding of it by the time you're spend some time doing it and going through it and just living it basically. So anyway, that's a few thoughts on that from the construction side. I think that's about. Yeah, I had one more, just a few other, some details, so on some construction items, but
It looks a little looks a little deep.
The lazy river. But
Yeah, that looks like 6 inches too deep, Jason.
yeah, it is correct. Yeah, that's a builder on here designed the whole system. The Florida code for lazy river is 3 feet deep. But he called me up and said, "Do you need to change your plans? We build them to 3'6". I was like, "I don't. The code is 3 feet. I'm not changing my plans. You need to do the 3." It's like, "No, we do 3'6". You do whatever you want to, dude. But the code says 3. My plans are 3. They built it at 3'6" because that's what they do. And it got down to closing and all these. I mean, it was opening day, and people were standing in these windows with their little duckies
Floats on. Yeah.
floats ready to go. When's the pool? Come on, when's it opening? And the code inspector came out there and looked at it for opening and was like, "That says 3'6" on the file. That's supposed to be 3." So they shut the whole thing down. Had to raise the floor. And, shut it down for a month or two.
The pool was completely done.
I was done. So anyway, haha, funny story. So, but